So yesterday, or today I guess, I don't know, you learned about the imaginary number I. So they use the letter I just because it's called an imaginary number. And that's a play off of the fact that it's not a real number. Okay, so it's not a real number as in all the other numbers you know in your world. So the only non-real number that you know of is the imaginary number I. But the thing is, sometimes you want to add an imaginary number and a real number. And so when you do that, you get something we call a complex number. And we call it complex because it's exactly that, it's complex. And as you look here, we've got a plus bi. That is just one number. It's a real part. A is the real part, and b is the imaginary part. And so it's, even though it looks like an addition, it's really just one number, a real part and imaginary part being added. So for example, we have here, we have 2 plus 3, or 2 minus 3i, that's a complex number. We have negative 3 plus 2i, that's complex, and then we have just 4i is also complex. See, the thing is we can't put those together because just like if the I was an x, we can't take and add these together because the 3 doesn't have an I on it. And so what happens is you can't graph complex numbers on the xy axis because the xy axis are real lines, the real number lines. And so what you have to do is you have to actually change it, and it's not an xy axis anymore. It's now a real axis and an imaginary axis. So right here we have the real axis, so our real numbers are going to go on here, and here we have our imaginary axis, they're going to go on there. So if we graph our points from above, so we have 2 minus 3i, all right, 2 minus 3i. So 2 is on the real number, so I find 2 on the real number. And then negative 3i, so I find negative 3 on the imaginary number, and that goes right there. So this would be 2 minus 3i. It's kind of like saying that x is 2 and y is negative 3. All right, so then we go to our other one. We have negative 3 plus 2i. So it's negative 3 on the real axis and a positive 2 on the imaginary axis, and they meet up right there. So this would be the point negative 3 plus 2i. And then just straight up 4i. There is no real number. The real number is 0. So if we're looking for 4i, just go up to 4 on the imaginary, and that would be that point right there. And so that's how you graph complex numbers. So I guess on here I ask you to graph those 3. You can try and do them without me. Otherwise, negative 4 minus I, so we go negative 4 on the real minus I in the imaginary. It matches up right there. So this is negative 4 minus I. Straight up 5, well, you just find 5 on the real axis and you put a point there, so that's 5. And then 1 plus 3i, you find 1 on the real axis and 3 on the imaginary, and it matches up right there. So 1 plus 3i. All right. Now this is kind of a little bit weird if you look at this, but the book gives you some problems like this, so I talk about it. So if you know that a plus bi equals c plus di, then the real parts have to be equal, so a has to equal c, and the imaginary parts have to be equal, so b has to equal d. And here's how you'll see that, because that seems really silly. If we look at this example right here, we have x plus yi equals 8 minus I. So the real parts are x and 8, so that means x must equal 8. The imaginary parts are yi equals negative I, and the i's are the same thing. So if we're looking at this, y equals the negative, and we need a number there, so we put a negative 1. All right, let's get to the actual good stuff here. Adding and subtracting. You're going to add and subtract just as if these were x's and y's. So adding's real easy because you just add your like terms. We have 4 plus 3, well that's 7. And then we have negative I plus 2i, that'd be plus 1i. We still have 1i left. Let me make this a little bigger as I talk about the rest of these. Now this next one, you have this minus sign, and just like with the x's and stuff like that, I need to distribute that minus sign in the bubble after it. So I still have 7 minus 5i, but then I'm going to have minus 1 and then plus 5i. So if we have minus 5i plus 5i, those actually cancel each other out. So we're left with 7 minus 1 is 6. And on our last problem here, let's see here, I have a 6, and then I have a minus, that needs to be distributed. So I get plus 2 minus 9i. And then that plus doesn't do anything, so I can just write down the next one. That plus, even if I distribute it, wouldn't change anything. And now I look at combining my like terms. I have 6 plus 2, well that's 8, and then minus 8 is 0. So these all actually cancel out. That's kind of weird, but it did. And so then for my i's, I have negative 9i, and plus 4i gives me negative 5i. It's not always going to happen that they cancel out. Sometimes they don't cancel out, so you get 2 plus 5i or something like that.